All right, so in a learning theory project, psychologists discovered that f of t equals zero point 0.8 divided by 1 plus e to the power of negative 0.2 t is a model for describing the proportion of correct responses f of t after t learning trials. So find the proportion of correct responses prior to the learning trials taking place. So prior to the learning trials taking place, that means the number of learning trials is equal to 0. So f of 0 equals 0.8 divided by 1 plus e to the negative 0.2, negative 0.2 times 0. So let's try this out. So 0.8 divided by, parentheses, 1 plus second e to the negative 0.2 times 0. Oops, 0. It'd be 0.4. Now, what about after 10 learning trials? So 10 learning trials, t learning trials, so t equals 10. So f of 10, it's supposed to be a t there. It looks like an f. It's 0.8 divided by 1 plus e to the negative 0.2. So you just plug in 10. Plug in 10 here. Grab that. 0.705. So I haven't been teaching a lot of this here, but what is the limiting size? So the limiting size is basically it's a value that this approaches as x approaches infinity. And the limiting size is going to be your numerator, c. And we call c in this case 0.8. So the limiting size is going to be the numerator, the numerator of the equation. So the limiting size, if you were to graph this, what you would notice is in the graph, and it would be hard to see this. I'll try here. I'm going to have to do some adjusting here. So 0.8 divided by 1 plus second e, and I might have to do some adjusting the windows. X, got to use x to the t, and I'm going to change the windows. My highest y would be 0.8. So I'm going to go from 0 to 1. My x min, I need to x max, you need to see what's happening at the very end because you want to see the limiting sizes as I go forever and ever to the right, what's happening. So if I do graph, you'll see it's approaching 0.8. Now, there is more curve of the graph, but I'm so far zoomed out. That's why I said this was not going to be a good trace. It wasn't going to be a good. Now, it's not really 0.8. It's a number so close to 0.8 that they've just rounded to 0.8. But as I go on forever, the graph y, as x goes forever, y is approaching 0.8. And so there's a horizontal asymptote basically at 0.8. So that's like 0.79 repeating forever. It's not actually 0.8, but your calculator can't really express all that. But anyways, if you want to simplify it, the limiting size is just going to be whatever the denominator is for this equation.